Welcome to the presentation on special theory of relativity proposed by Albert Einstein in 1905. This theory changed our understanding on space, time and motion, forming the foundation of modern physics. Theory. For Einstein, physics was based on Newton's law of motion, which worked well for everyday speeds but failed for objects moving close to the speed of light. The Michelson-Morley experiment showed that the speed of light remains constant regardless of the observer's motion. This surprising result led Einstein to propose a new theory, the special theory of relativity. Einstein's two postulates. Einstein based on his theory on two simple but powerful postulates: the principle of relativity. The laws of physics are the same in all inertial frame of reference, that is, frames moving at constant velocity. For example, if Bob is sitting inside a smoothly moving train and tosses a ball up, it behaves the same way as if the train were stationary. Meanwhile, Anne, standing on the platform, sees the ball move diagonally, but the laws governing its motion are still consistent for both observers. The constancy of the speed of light. The speed of light in vacuum, approximately 3 into 10 power 8 meter per second, is the same for all observers, no matter how fast they are moving. Inertial reference frames. An inertial reference frame is one that moves with constant velocity, neither accelerating nor rotating. There is no absolute rest, all motion is relative. Bob is sitting inside a train moving at constant speed, and Anne is standing on the platform. To Anne, the train and Bob are moving forward, while to Bob, the platform and Anne are moving backward. This shows that motion is relative. There is no absolute rest. For example, a passenger sitting inside a moving train is at rest with respect to the train, but moving relative to an observer standing on the platform. Lorentz transformations. To describe how measurements of space and time change between moving frames, Einstein used Lorentz transformations. These equations show that time and distance are not fixed, they depend on the observer's motion. They ensure that the speed of light remains constant in all frames. Time dilation. One of the most famous effects of relativity is time dilation. When an object moves very fast, time passes more slowly for it compared to a stationary observer. Mathematically, the relation is given by t equal to t naught divided by root of 1 minus v square by c square. This has been confirmed by experiments with atomic clocks and explains why astronauts in high speed travel age slightly slower. At the speed of light v is equal to c, the time dilation becomes infinite and time appears to stop for the moving object relative to a stationary observer. Relativity of simultaneity. According to relativity, simultaneity is relative. Two events that appear to happen at the same time for Anne, who is at rest, may not appear simultaneous to Bob, who is moving at a different speed. This shows that time depends on motion. Length contraction. Another consequence is length contraction. Objects moving at high speed appears shorter along the direction of motion. If L naught is the original length, the observed length is L naught into root of 1 minus v square by c square. This contraction becomes noticeable only at speeds close to that of light. Einstein's equation and energy mass equivalence. Einstein's most famous equation, E is equal to mc square, expresses one of the most profound ideas in physics. The mass and energy are two forms of the same physical entity. It tells us that a small amount of mass can be converted into tremendous amount of energy. Since the speed of light is a very large number and its square makes the conversion factor enormous. This principle forms the foundation of nuclear power and atomic energy. In nuclear fission and fusion reactions, a small fraction of mass is lost and converted into energy, which can be harnessed for electricity or in weapons released explosively. A striking example of this equivalence is seen in pair annihilation. When a particle like an electron and its antiparticle a positron meet, they annihilate each other completely. That is, it disappears, producing pure energy in the form of gamma rays. This process perfectly demonstrates Einstein's principle. The entire mass of both particles is transformed into radiant energy. To summarize, Einstein's special theory of relativity replaced the old concept of space and time with the unified concept of space time, where time slows down, length contracts, and mass increases as the speed approaches the speed of light. The speed of light remains constant for everyone. This theory laid the foundation of modern physics and cosmology. Thank you.